All right, this is your Unit 1 exit exam resource page. You can use this on the exit exam. I will be providing some notes and examples, but you can add anything you want that you think will help you on this exit exam. I'm going to be providing an example of a level 3 question from each objective. So let's look at 1.1. This was simplifying expressions. There's no equal sign in an expression. We're not solving for x. All we are doing is simplifying the expression. We are not solving. So always distribute first. That is what we're going to be doing. So distribute is when you see that set of parentheses and you need to multiply the number outside the parentheses by the terms on the inside. So remember, we will be multiplying when we're distributing. So 9x and x squared, those are not part of the distributing, so we're just going to bring those down. Negative 2 times 5x is negative 10x, and negative 2 times 7 is negative 14. Next, we're going to combine like terms. We can't combine the like terms until the parentheses are gone. Like terms must have the same variable raised to the same exponent. So the like terms that I see here are 9x and negative 10x. There are no other like terms. X squared is by itself and negative 14 is by itself. So I am going to write this as x squared, combine 9x and negative 10x, which is negative 1x, and bring down negative 14. So I have x squared minus x minus 14. That is my simplified expression. In objective 1.2, we solved multi-step linear equations. So we are solving for x now. There is an equal sign. We will have a value at the end that x equals. So the goal here is to isolate the variable. We want to get x by itself. We're going to use inverse operations to get the variables to one side and the constants to the other. So we want x equals a number as our answer. So just like in simplifying expressions, we're going to distribute first. 3 times 3x is 9x. 3 times 4 is 12. And we'll just bring down the rest of the equation. Next, we're going to combine like terms, and the like terms have to be on the same side of the equal sign. So I can add together 12 and negative 5, but I cannot include negative 8 because that's on the other side of the equal sign. So this becomes 9x, 12 minus 5 is 7, equals 8x minus 8. Now I'll use an inverse operation because I want to move all the x's to the left and the constants to the right. So subtract 8x. To cancel it out on the right, subtract 8x. So this becomes x, or 1x, plus 7 equals negative 8. The last inverse operation I'll need to do is subtract 7. So x equals negative 8 minus 7 is negative 15. So x equals negative 15 is my answer. In objective 1.3, we were solving inequalities, graphing the solution, and writing the answer in inequality notation and interval notation. So the most important thing here is when you're solving, if you multiply or divide by a negative number, the inequality symbol flips. So first thing you're going to look for is parentheses. There are no parentheses in this, so we don't have to distribute. There are no like terms I need to combine. Remember, like terms have to be on the same side of that inequality. So now I'm going to move all of my x's to the left side and my constants to the right side using inverse operations. So I will subtract 2x to cancel it out here. Subtract 2x on the left. Now I have negative 9x plus 7 is greater than negative 2. subtract 7, and now I have negative 9x is greater than negative 9. Divide by negative 9. Okay, so now I'm dividing by a negative number. That means this inequality symbol has to flip around. So this becomes x is less than 1. So this is my answer in inequality notation. So I've done that. Now I need to graph it and write the interval. So I have a key for you here. For open intervals, you use parentheses and an open circle. That's for greater than or less than. A closed interval uses brackets and a closed circle, and that's for greater than or equal to or less than or equal to. So here are your two charts here that you can use to help you graph. So I'm going to put 1 in the middle here because my answer is x is less than 1. So because I'm using a less than symbol, that tells me I need an open circle on the graph. Because this is the symbol, so I'm using an open circle. And because x is less than, I'm going to be pointing down the number line to all the numbers that are less than 1. For interval notation, I need to use parentheses with the 1, and because it's pointing down the number line towards negative infinity, that's what goes on the left with a parentheses. Infinity always uses a parentheses. For infinities, always use parentheses, even if the other side is a bracket. Okay, and for the final objective in Unit 1, we solved multi-step literal equations. So similarly, for solving regular equations, like up here, we're going to use inverse operations to rearrange the equation. In other words, we're going to solve for the given variable. So this example is telling us to solve for x. So I'm going to highlight x just to remind myself that that is my target. That is what I want to get all by itself on one side of the equal sign. I need to move everything else away from x. So you're going to start with looking at the side that x is on. What is the term that is farthest away from x? So the 4 is right next to it. I would say the farthest away is 5. X is being divided by 5 right now, so the inverse operation would be to multiply by 5. And that would cancel the 5 out on the left. I have to do the same thing to the other side. I need to multiply that entire side by 5. So I will rewrite this as 4x equals 5 times negative p minus 2n. Now I have parentheses, so I need to distribute. So I have 4x equals 5 times negative 1p is negative 5p. 5 times negative 2n is negative 10n. So remember, I'm still trying to target x here. So the last step to get x all by itself would be to divide by 4. So x equals negative 5p minus 10n over 4. So I have solved the literal equation for x.